Hey guys, welcome back to another video. Today we're doing Leetcode problem 323, number of connected components in an undirected graph. So in this problem, we're given a graph of n nodes and an integer n and an array of edges. And we want to find how many connected components are part of this graph. So I have one of the examples here. See, we're given n equals 5 and these edges here. And you see they're reflected in the graph here. And we can kind of see that the answer here would be 2, because this is a component and then this is another one. So we know anytime we're dealing with a graph, we're going to want to play around with BFS or DFS. And I think for this problem, DFS works well because you want to go ahead and kind of exhaust out and go as deep as you can and exhausting out each of these components. So, a good way to do this kind of just be going over each of these little nodes here. And then every time you see one, you kind of just mark it as visited. That means you won't return back to it. So say, start off doing DFS on 0. We'll cover 0, 1, 2. So right there, we can say that's one component. Then we can kind of check for every node since we're given the number of nodes. So we can check for 1. We'll see it's already visited. So we won't visit that again. Go to 2. We'll see it's already visited. So we'll skip that. Then we'll hit 3. See 3 isn't visited. So we'll start running DFS on it. That'll get marked off. And then we'll hit 4. That'll get marked off. So we'll know that's a second connected component. Then we'll check 4 again, and we'll see that we already saw 4, so we won't have to do DFS on it. And that should be all for this problem. We can go ahead and put it in the code now. Okay, so first things first, we're going to want to turn these edges into a graph. So we can use the default dict. That way we don't have to keep track of if we've seen anything or not. We can just append it to that list. Then we can just iterate over the edges. And since this is undirected graph, these connections will go both ways. And, just to show what's going on here, this will kind of generate a graph via an adjacency list where kind of look like this, where 0 is connected to 1, 1 is connected to 0 and 2, 2 is connected to 1, 3 is connected to 4, 4 is connected to 3. So kind of just build out this adjacency list. So now they have the edges built. We can build out the DFS. We can also iterate through all the nodes and hit that DFS. So we know if the node is visited and keep track of if we visited or not. So we'll check that. And then say if it's not visited, we'll run DFS here. And then we can increment our answer. So let's make those variables. And visited, set to false. So this will just represent node, visited or not. Now we can do the same thing in the DFS check if it's visited. So if it is visited, whoops, we just return. Otherwise, we can just go through all of its neighbors and call DFS on it again. So for neighbors, and graph node, call DFS on that. And one thing we have to do, we're not marking the nodes as visited yet. So we can do visited node and set it equal to true. So that should be all for the DFS here. It's pretty simple. We just want to make sure we hit all the nodes. And, we're doing this here, same thing, making sure we're just checking every nodes. A good example of a case would be like, say we have 0 that has no connections, it's empty, 1, 2, so this is kind of just 3 different connected components. We'll go over 0, it wouldn't be visited yet, so we'll hit DFS on that and increment answer by 1, and then we'll see it'll just kind of return out. It'll set to true, and then it doesn't have neighbors. We'll do the same thing for 1. It's not visited yet, we'll call DFS, and it'll just turn out of that, set it to true. And then 2 will end up doing the same exact thing. Then let's say, this is connected to 1, this is connected to 2. On 0, we would visit, since it hasn't visited yet, and then we'd mark it true, and then we'll run DFS on 1. It'll set to true. These actually will connect to each other. So 0 doesn't have a connection, but this will also go to 0. So on 2, we'll hit back here, and this will be 1 as well, sorry. Since it's an undirected graph, they'll connect to each other, but on the 1 run, we'll check the neighbors, we'll check 2 and 0. 2 will go through again, get marked as visited, and then it'll go back to 1. And it'll be just return out, and then it's just the 0 from here is left, and it'll return out again. So intuitively that'll work right there. So we can just return answer. Test cases pass. We can submit that. There you go, passes. So I hope this helped. If you have any questions, feel free to comment below. But thanks.